Today we are exploring diagnostic triggers and root causes in the blast furnace operation. Operating a blast furnace is much an art as it is a science. And today we are focusing on a systematic approach to process troubleshooting. Whether you are an operator or an engineer, understanding these triggers is the key to maintaining a stable productive furnace. So, why does diagnosis matter so much? So, it's a simple. The sooner you identify the early sign of process deviation, the easier is to prevent major upset like hanging, chilling, or the formation of a scaffold. By diagnosing issues early, we maintain efficiency, productivity, and extend the campaign life of the furnace. Ultimately, this allows for data-driven decision making rather than guesswork. As the saying goes, understanding what is going on inside the blast furnace is the operator's primary task. One of the most common challenges involves gas flow and permeability. You will see triggers like a high delta P or high K factors which indicate resistance to gas flow or the channeling where gas rushes up to the wall. The root cause often point towards fines in the burden, especially when more than 3% of the material is smaller than 5 mm, or poor screening in the stockhouse. Other factors include burden distribution imbalances and cohesive zone blockages that restrict the smooth descent of the gases and create many other type of major abnormal situation. Next, let us talk about the thermal instability. A primary trigger here is a drop in hot metal silicon or a decrease in hot metal temperature. You might also notice an increased burden descent rate. Why does this happens? Usually it's due to increased direct reaction caused by poor gas solid contact or high heat losses. We have also come across one of the my presentation of racing furnaces. There also it has been well established. So variation in the raw material quality and increased gas volume can also drain the furnace thermal reserve, which leads to a cold hearth and a nearly chilling conditions. The hearth of uh, the health of the hearth and the dead man that that pillars of coke in the center is vital. Triggers for trouble include a low dead man cleanliness index, high level of Fe or MnO in the slag, and a poor slag metal separation. These are often caused by poor coke quality, especially low CSR or high fines, which choke the dead man. Even as water leakage into hearth or long furnaces stop can lead to solidification, making the hearth inactive and difficult to cast. Now, moving to the combustion zone, we monitor two-year and we can say others area raceway abnormalities in many cases. Signs of trouble include two-year blockages, coal or gas backups, and formation of a bird nest of unburned material. The root cause frequently involved a scaffold fall or unmolten material dropping from the raceway, or many times we come across a unprepared burden is descending down or peel off. So additionally, the lance misalignment or low blast kinetic energy can prevent the pulverized coal from burning efficiently, also leading to unburned car in the top gas. Now, a silent killer in the furnace operation is alkali and zinc. recirculation. You will identify this through high alkali in the dust, periodic pressure spikes and increased stack temperatures as scaffold begin to form. These elements enter through the body in our coal and recirculate if there is a low slag basicity or poor slag removal. Operating with low productivity or low central gas temperature further encourages these elements to condense and build up on the walls. So, to wrap up, uh, let's look at the diagnostic framework. To stay ahead, you must monitor early indicators like descent rate and delta P. You have to correlate symptoms. For example, a high delta P combined with a high top temperature almost always means channeling. Always check your raw material first for fines and consistency before blaming the equipment. Finally, use predictive indices like DCI and flame temperature to see problems before they manifest. Remember, diagnosis is not just about fixing problem. It is about preventing them through systematic monitoring.